Hello again. In this example today, we're going to be using an idea from chemistry, specifically about calorimetry. So we have this scenario where we have a beaker of water being heated up by a Bunsen burner or a flame or some heat source. The general equation for that, which I will write out now, is Q, which is the power, is equal to M, the mass, times Cp, which is the heat capacity, times the change in temperature, which I call delta T, which is T final minus T initial over the time it took for that temperature change. So what does that look like? Well, in our scenario, we're going to be saying that we have a beaker full of water. So for water, the heat capacity is 4184 joules per kilogram degree Celsius. And it's okay if you don't understand what all this means. We're just using this example to show its functionality in Excel. And then we're going to say that the mass of the water in the beaker is 0.25 kilograms. One thing that's important to note with what I'm doing here is I am keeping the cell with the units separate from the cell with the numbers. Excel doesn't let you mix numbers with text when you're doing these kind of calculations. So we have different trials where we're trying to find out the power output of the Bunsen burner. We know the mass, we know the heat capacity, and then we're going to do trials to figure out the temperature change over how long it took that temperature to change. So for these experiments, I'm going to set up a table of data. I want to know what trial number. I want to know my initial temperature of the water. I want to know my final temperature of the water. I want to know how long it took, which would be my time. And then I'm going to do an intermediate calculation here where I actually calculate my delta T, and I have an autocorrect, it won't do that in yours. Delta T over time. So this column, I'm going to be doing calculations in. And then my overall goal is to calculate my power, my Q. And whenever I do data tables, I include my units. So my initial temperature is going to be in degrees centigrade. My final temperature is going to be in degrees centigrade. My time is going to be in seconds. My delta T, my change in temperature over time is going to be degrees centigrade per second. And then my Q, my power, is going to be in watts. Just zooming out so you can see everything. So I'm going to do 4 trials. So I'm going to go ahead and fill in my trial numbers. I have trial 1, trial 2, trial 3, and trial 4. For trial 1, my initial temperature is 25 degrees Celsius. My final temperature is 50.2 degrees. The time it took for that was 45 seconds. For trial 2, my initial temperature was 26.2 degrees. My final temperature was 48.8, and the time that it took for it to change was 40 seconds. For trial 3, my initial temperature was 23.8. My final temperature was 41.8, and the time it took for that was 30 seconds. For my last trial, it went from 27 degrees to 58.2 degrees in 50 seconds. And I'm just going to format this so it looks a little nicer. I'm going to select all my cells and center them. And that's that button up there. You can change the alignment. Right and left and center. I personally like how it looks centered. So in these two columns, I'm going to be performing calculations. So let's go ahead and start by calculating my change in temperature over time for each trial. The way I'm going to do that is I'm going to hit equals. Okay, and then I need my change in temperature, which will be final temperature minus my initial temperature. So I'm going to put that in parentheses, my final temperature minus my initial temperature, and then divided by the time that it took. So can you see that, how we change this cell's value? That gave me of 0.56 degrees per second. And sure, if I wanted to, I could go through and type that out for each and every cell. But what did we learn last time? If we select this and drag it down, it'll copy that formula over. So now it's doing it for each trial without me having to type it. Now I'm going to do my final calculation for finding the power. And in this case, I have this equation up here of M times Cp times this value that I've already calculated, the change in temperature over time. So we're going to do the same thing that we did over here, except now we're using a different formula. So we're saying my Q is equal to my mass of the water times the heat capacity of the water times the change in temperature per time. There's one important thing about this formula though. We have to make sure that we lock the cells for the heat capacity and the mass. And we do that by putting in dollar signs. Hit enter, select the cell, hover over until you see the black cross, and pull it down.